As we move into this incredibly practical section of our math syllabus, let's just take a moment to make sure we know what's going on the formula sheet that will be given in our exams at the end of the year. We've really come a long way in terms of financial maths. We started just by looking at simple interest and compound interest, and that was here with these first two formulae that you're looking at. So A equals P1 plus NI, that's a simple interest formula, and then when the N, the number of time periods, moves outside of the bracket, that's a compound interest formula. And both of those are important and both of them are relevant. Now, in general, what you'll find is that most of your banks are going to be talking to you about compound interest. But simple interest does occur, and most often that occurs when we take out a hire purchase loan. Then we will see that they charge an extortionate amount of interest, and they work it out on a simple scale. And then in grade 11, we started to learn about depreciation. So that's when we start to subtract the interest on these amounts. And we have two types of depreciation. So that's as something is losing value over time. So we've got straight line depreciation and then reducing balance depreciation, which again is the more common one in our everyday life. Okay, and then later on we're going to move on to future value annuities and present value annuities. Such a fascinating section of the syllabus. But for this video, we're focusing just on the intro, and so we're going to just make sure that we know how to apply these formulae to grade 12 type questions. Okay, and then this one down here is in a red block on its own because this formula that compares the effective and the nominal interest rate is not going to be given to you on the formula sheet. So this one needs to be in your brain. And then just to refresh your memory, the nominal interest rate, you can see it here with all of these n's, is linked to the number of time periods. Whereas the effective interest rate is actually just the equivalent, but annually. So let's call that the annual equivalent. Let's have a look at some examples of that. So we need to calculate the effective interest rate, in other words, annual, if the nominal interest rate is 7.24% per annum compounded monthly. So they just want us to convert, and we need to use that formula that should be memorized. So the formula says 1 plus the effective rate is equal to 1 plus the nominal rate divided by the number of compoundings raised to the number of compoundings. Okay, so they want the effective interest rate, that's what they want there. And we are given a nominal interest rate of 7.24%. So we're going to put that in there. And it is compounded monthly, and monthly means there are going to be 12 compoundings. Okay, so that's very helpful. We're going to say 1 plus I effective is the thing I'm looking for. And let's substitute in here. 1 plus I nominal is 7.24. Okay, that's in percent. So I like to put the 100 at the bottom because when you divide by 100, you make this into a percentage. Okay, and we are compounding monthly, so 12, not just 100, but 1200. Okay, and then for how many time periods? 12 time periods. And then what we can do is we can take the 1 that is currently on this side, we can move it across and subtract it, and that way we can do our whole calculation in one step, which would mean that we don't lose marks for rounding off prematurely, because that is the biggest mistake that students make in this section. So if we type that all into our calculator, we end up with 0.0748, etc. And that's the I value. But what they actually want is the effective rate. So to get this to be a rate, I then need to multiply by 100 again, so that I can get it into percentage form. And so the effective rate is equal to 7.49% annually. All right, and then the next question is just asking us to do the reverse. So the nominal interest rate, if the interest on an investment is compounded quarterly and equal to 9.52% effectively. Okay, so we need to know this formula. 1 plus I effective is equal to 1 plus I nominal over the number of compoundings to the power of the number of compoundings. Now let's read the questions carefully to make sure we know what we want. Nominal interest rate is now the thing that is in question. Okay, they tell us that the effective rate is 9,52. So that's what's going to go in there. And it is compounded quarterly. So that's 4. And that 4 needs to go into the place of n in each instance. Okay, so 1 plus 9,52%. I'm going to write as 9,52 divided by 100. Because effective rate is always annual. So that's always just going to be 100. I don't need to worry about additional time periods. Okay, that's equal to 1 plus the nominal rate here is what we want to determine. So I nominal we don't know yet, but it must be compounded quarterly. That's what they've asked us for. Okay, now what I need to do is I need to solve this equation so that I can isolate the nominal rate. Okay, let's start by taking the fourth root on both sides. Okay, and I only need to worry about the positive one here because I'm working with positive interest rates. Okay, so we're going to take the fourth root of that, which is then going to leave us, let's have a look, 1 plus I nominal over 4 is going to equal the fourth root of this. Let's quickly calculate what is 1 plus 9,52 over 100. Remember, we don't want to round off yet, but we do want to make our writing just a little bit shorter. Okay, so I'm going to leave that as a fraction there in the fourth root. And now what I can do, similarly to what we did earlier, we're going to move this over. It's going to become minus 1. Maybe if we put it at the back here, it'll be more simple. And then we also need to get rid of this 4. So let's times by 4, which we're currently dividing by. And so we need to times by 4 on both sides. Okay, so now in an effort not to round off prematurely, we have really just put everything into one calculation. So we'll have I nominal is equal to 4 multiplied by the fourth root of this fraction. So the fourth root minus 1. Okay, and I can type that all into my calculator. And then again, be aware of the fact that we're working out I. So in order to get the rate, I'm also going to multiply by 100. Let's do that all in one step now. Okay, and I encourage you to calculate this along, even if it means you need to pause the video. But I want to make sure that you know how to use your calculator, because I'm not going to be sitting next to you in a test or exam to type the calculator. You need to know how to do that. Okay, so when I work all of this out, I get 0,09197. And then because we want that to be a rate, let's multiply it by 100. And so we end up with a nominal rate of 9,2, once you round that off, 20%. Let's have a look at some of our other formulae being put to good use here. Farmer Paul realizes that his tractor, that was valued at 350,000 Rand when he bought it new, has depreciated on a reducing balance to a value of 175,500 Rand over 3 years. And we need to calculate the annual rate of depreciation. Okay, I like to start and just put down the formula that is relevant to what I'm working with. So they told us it was reducing balance. So that's the formula. And that just guides me to know that I need an A value, P value, I value, and N value. Okay, and usually one of them is missing. And the fact that they specifically said there, calculate the annual rate of depreciation, we know that that's actually the I value that's going to be missing. Now the tenses in this question might be a little bit complicated, but basically the farmer would have started out with a present value of 350,000 Rand, and that would have depreciated to, somewhere in the future, 175,500, and that was over 3 years. Okay, so because it's depreciating, the future value is definitely smaller than the present value. Okay, and then we can substitute in. So 175,500 is equal to 350,000, 1 minus the I we don't know, to the power of 3. And now we just need to solve this equation so that we work towards making I the subject of the formula. Okay, let's start and divide both sides by 350,000. Okay, and where possible, we want to leave things as improper fractions just so that we don't have to have too many decimal places to deal with, because we can only round off in our final answer. Okay, so on the calculator, 175,500 over 350,000 is going to give us 351 over 700. And then, very similar to what we saw in the previous example, we're going to take the cube root here, and what we do to the one side, we do to the other side. Okay, if we do that, then that cube root and that cube end up cancelling each other out. So we have 1 minus I is equal to the cube root of 351 over 700. And now, let's move this minus I. If we move it over, it can become positive I. And then we'll just move this root across and we'll subtract it over there. So I like to work towards having I as a positive because it just makes my final step a lot simpler. So 1 minus the cube root of 351 over 700. Let's work that out. We get an answer there. I is equal to 0,2055 ... And so the rate of depreciation, therefore the rate, is equal to, and then remember to multiply that answer by 100, and we get 20,55%, which does seem to be a pretty standard rate of depreciation on things like vehicles. Okay, here is a great question where you get to put your newfound knowledge of logs to the test. Let's have a look. Ayanda bought a house for 950,000 Rand. It appreciated at an average rate of 6.5% per annum. How many years did he have the house if he sold it for this nearly 2.5 million Rand? Okay, so we're talking about an appreciation here, a house that is appreciating, and so that most of the time would be a simple compound interest question. So 1 plus I to the n. And then, as usual, just helpful to figure these things out over here. You're welcome to substitute straight in if you're comfortable doing that. Okay, Ayanda originally, the present value, originally bought the house for 950,000 Rand. Then, it really accumulated a lot of money till 2.468 million Rand. Okay, how many years? We don't know, but it's appreciating at a rate of 6.5% per annum. Okay, so it's just every year. We don't need to worry about any other compounding there. Okay, let's substitute those values in, and now we're ready to solve. Okay, I need to try and isolate this n value here so that I can solve. So let's start and divide both sides by the 950,000, because then I'll get the bracket on its own. Okay, and once again, I encourage you to leave your answer as an improper fraction until you need to work out that final answer. Okay, another thing we can also do while we're getting our calculators out is we can work this out, the inside of the bracket. I mean, BODMAS would tell us to do that already in grade 8. And we can leave that as an improper fraction too. Okay, so 2.468 million Rand divided by 950,000 Rand simplifies to this, and then 1 plus 6.5 over 100 simplifies to that. Okay, now have a look at this, grade 12. N is our unknown, and it is in the exponent. And we learned in our most recent video that we can make n the subject of the formula if we use logs. Okay, how do we do that? We say n is equal to log, and then this number here that was the base of the exponent becomes the base, and this number here that was on the other side becomes the number of the log. So in other words, log base 213 over 200 to the number 1234 over 475, and we can work it out and we can have our answer in years. And there we have it, 15,16 years. All right, just a word of warning on these questions. If they had said to us how many years or round off to the nearest year, then you need to be very careful and you need to say it would take, because it'll take 15 years and a little bit, he won't have, or his house won't have appreciated to this value until 16 years. So if they asked us to round off, which this question has not done specifically, but if it had, we would need to round off to 16 years. That's just one of the things I've noticed in financial maths. That's one of the areas that people seem to get tricked up.